All right, guys, we're going to take a look at our study guide. So graphing piecewise functions, level 1, graph the following function on the axis provided. So remember, whenever you're graphing, you need to look at y equals mx plus b, where plus b is your y-intercept and your m is your rise over run. Okay, so once you know how your equation is set up, it's really easy to do it. So you graph it for x, and these are your restrictions, right? So x is less than 0. So I go to x, all right, and I'm going to draw my restriction in for this graph. Anything to the left of it, because this is, remember, if you draw that, the arrow is going to the left. All right, so I need the graph drawn only in this area here, this piece right here, and I need to start at -6. So we're going to put a dot at -6, and the pattern is what? So y-intercept is -6, and my rise over run is -1 over 1, right? So that's going to be -1 over 1. So I'm going to go down 1, right 1. This is the pattern, right? Down 1, right 1, down 1, right 1. But that's the wrong side. So I'm going to go backwards to get the other side because I don't need any part of the line that's over here, right? I need everything that's on this side. So instead of me going down 1, right 1, down 1, right 1, I can go backwards and go up 1, left 1. See how I get back to the same place? Up 1, left 1. So this is going to be up 1, left 1, 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 and so forth. And you can just join it with a straight edge. Okay, just join all these points with a straight edge. All right, and you do need to know whether it's open or closed there. What kind of circle would this be? This is an open circle, so make sure that that is open. Open, why? Because it doesn't have that line underneath. So that line means closed. All right, without that line, it's open. So that's this graph, and it goes on forever in that direction. I'm not crossing where x is to the right of 0 because I only need values for the left. All right, graphing the second one. So again, the same thing, plus b is -18. But here I'm running into a problem. My graph only goes to -10. So how do I find that? Well, let's look at what the rise and run is. The rise and run, or the pattern for this one, first of all, is 3 over 1. So I'm rising 3 and running 1. All right, this is for values that are greater than 5. So remember, if you don't know what that looks like, you draw a line from both sides. So it's going to the right of 5. So wherever 5 is, so the second one, you are not going to draw a graph anywhere over here. It's only on this side. All right, now we're going to start at -18, and the pattern is up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. Okay, until we get to a point that is on my graph. So if I start off at, you can imagine, in fact, let's not imagine, I'm just going to draw it for you. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so this is going to bring me right to 0. Okay, so if my graph was at -18, I'd have a dot at -18, right? And then I go up 3, right 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go up 3, 1, 2, 3, right 1. So now I'm at -15. Up 3, 1, 2, 3, right 1. So now I'm at negative. So I'm going up by 3 each time. So that's going to be -12. And then now I'm at 2 for x. And again, I'm still not on the graph, so I'm going to keep going. Up 3, 1, 2, 3, right 1. So now I'm at 3 at x, and up 3 is I'm at -9? Yep. So now I'm on the graph at -9, 3. Okay, so -9, -9, 1, 2, 3. So this is the point right here, right? But I'm not going to graph it because I need the point on this side. And then I'm going to keep going. So now instead of going here, I'm now on the graph. I'm going to do it here. So 1, 2, 3, 1. 1, 2, 3, 1. So this is open or closed at the point I'm at my line, open. So this needs to be open right there. And then keep doing it. So 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And then draw it with a straight edge. So just keep doing it until you get back onto the graph. So if you're off the graph, you can kind of sketch it, but you're just following the pattern until you get back on the graph. So this is your piecewise function that looks like this. And on Delta Math, you would just go to 5, -3, and then draw a point to another corner over here, which would be, you could do 8, positive 6, and then just drag it over, okay? So this is what my two piecewise functions look like. All right, graphing piecewise, oh, I guess I did 2 examples. Level, I guess this might be level 2 actually, because there's 3 of them. So level 2. Okay, now you have 3 piecewise functions. So I'm gonna separate this by what it is. So less than -3, so here's -3. 1, 2, 3. So to the left is gonna be this one. Then x equals -3. Then between -3 and 1, so between -3 and +1 will be this last one. So I kind of graph sketches so that I remind myself not to go beyond what I have put out there. So let's start with this first one. So again, it's the same thing, y equals mx plus b. All right, so the plus b is 2, and my rise and run is 1/1. So I start off at 2. All right, this time instead of me doing markings in a different, I'm just gonna kind of do the pattern without marking it down. I start off at 2, and this is the one that needs to be less than on this side right here. So if I go up 1, right 1, up 1, right 1, up 1, right 1, I'm going in the wrong direction. So that means I need to go opposite. So instead of up 1, right 1, I'm going to go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And that at that point is open. So I hit my line, so I'm going to do open. Then down 1, left 1, point, down 1, left 1, 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 and so forth. All right, so that's going to be this line here. And again, on Delta Math, you don't need to do so many points. Just get this first point and then pick one more point and then drag I think you double click it to make the arrow come up. All right, so open circle right there. Then I've got when x is -3, so at x equals -3, y is equal to 1. So when x is -3, y is equal to 1. So I'm going to put a closed circle there. When x is -3, y is equal to 1. Then between these two lines right here, I've got 2x plus 4. So my plus b is 4, so I go to 4. Okay, so 4. And again, I just want to hit the pattern between these two lines, right? So this is 2/1, so up to right 1. So up to right 1. And I'm within my pattern here, right? So that's okay. Up to right 1. Now I'm out of my pattern. So let me go backwards. Down to left 1. Down to, so at 4, sorry, let me do that again. So 4, starting at 4, up to right 1. So right here, I actually did that the wrong place. So starting at 4, up to right 1. So here, then up to right 1. Okay, now I'm past. So now to go opposite, down to left 1, down to left 1, down to left 1, down to left 1, down to left 1. Here we go. So it's these 4 points right here. And I need the one with -3 to be open. So over here, open. And the one with 1 to be closed. So over here, closed. Then you join in those lines up. Boom. So this graph looks like this. This piecewise function looks like this. All right, so just be careful with your open and closed and make sure that your domain restrictions, you don't pass those. All right, so looking at another question. So let's talk about absolute value and piecewise functions. Okay, so absolute value and piecewise functions. Okay, there's several ways of doing this, but by far the easiest one is just because absolute value. So again, let me remind you, when you take the absolute value of, let's say, what can I write this? Let me write it here. -3. The absolute value of -3 is 3. The absolute value of 3 is also 3. So when you're trying to solve an absolute value, you don't know whether that was the negative portion or the positive portion because they're both equal to 3. So what you do is you set the equation equal the positive version, and then you also do the negative version. So I'm going to do the positive version, which is exactly the equation, which is 10 minus 2x is equal to 3. Then you're going to do the negative version. The negative version is if it's a negative outside, all right, you distribute the negative. So you would get -10, all right, and then you'd get negative times a negative is a positive, so positive 2x. And you're going to set both of those equal to 0. Why did I set it equal to 3? Oh, because I was doing this example, my bad. Both of those are going to be equal to 0. So the positive version and the negative version. And I'll show you why in just a second. Let's just work it out first. All right, so again, take the 10 to the other side. It's going to be -10. And now divide both sides by -2. And you're going to get x is equal to 5. All right, then here, take the negative 10 over to the other side. You're going to get positive 10. Then divide by 2. So you're going to get x is equal to positive 5. So you have an equation for x is greater than 5 and for x is less than 5. Okay, so what does that mean? So if I'm just going to just do a rough sketch somewhere, something like this, because I just need to know what happens. This line looks like this. So if I had y equals negative 2x plus 10. Okay, this is just a rough sketch. All right, where's positive 10? Over here. Negative 2x will be down, right, right, down to right 1, down to right 1. So it looks like this, right? Where this crosses is this 5. So it crosses right at 5. Now, you know absolute values look like a V, right? They cannot be negative. So what it is this part of the line is reflected back up. So it really looks like this. So there's a line that's to the left of 5, and there's a line that's to the right of 5. Okay, so I'm going to write that down. So for x to the left of 5 and x to the right of 5. Now, one of these, because it does include the actual 5, you need to put a line underneath is equal to. It doesn't matter which one, but one of those. So which part of the graph is equal to which? Like the positive version is this one or the positive version is that one. You have to figure that out. So let's take a look at what we did, right? So this part of the graph right here, it crosses where y is positive 10. So when I look at my two equations, right, which one was positive 10? Okay, the one that was positive 10, so you got, well, I guess I can't write them down here. The one that's positive 10 is this one as it is, right, without me negating it. So that means this part, the left, is the one that's positive 10. So this is going to be 10 minus 2x. And the right is the one that's going to be negative 10, because if you extend this line this way, see, it's going to have a y-intercept of negative 10. So the one on the right of 5 is going to be the one with negative 10. You can write that out as just the negative of this, 10 minus 2x, or because we already multiplied it out here, you can write it out as negative 10 plus 2x. Either one of these answers will work. Okay, so you just need to kind of rough sketch it just to see which part of the graph is on the left and which part is on the right. All right, write in piecewise functions from graphs. Okay, so express the function graphed on the axis below as a piecewise function. Okay, great. So remember, it's always y equals mx plus b, right? Now, if you're off the graph, again, you find the pattern to get you back on the graph. So let's first draw my restrictions. So this is my domain restriction right here. All right, so this is to the left of negative 3. So for all values of x to the left of negative 3. Is it an open or closed circle? It is closed, so that means there needs to be a line right underneath it. All right, on this one, it's all values to the right of 4. So for x to the right of 4. Is it an open or closed circle? It's open, so that needs to be open. Now you need to write down what this equation of this graph is, right? So to write that equation out, you extend the line. And if your line is off the graph, so if you extend your line, it's easier to see. And if you're not sure, you can do the pattern. So it looks like it's higher than 1, maybe 2, but I'm not sure. So I'm going to find the pattern. The pattern is rise over run. So find two corners. Here's a corner. Here's a corner. I'm going up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2. Wait, I lost it. Up 2, right 1, up 2, right 1, up 2, right 1. So I am right that it crosses at 2. So this equation of the line is it crosses at 2. All right, so it's positive 2. And my slope, my rise and run is up 2, right 1. Up 2, right 1. And then write it in simplest form. Up 2, right 1, right? So this is y equals 2 divided by 1 is 2. So 2x. Actually, you don't need to write that part. Sorry. 2x plus 2. Okay. Now you're going to write this equation. But when I try to do this with my ruler, whoa, it's way off the graph. Okay. So again, let's start with my, my pattern. So find me 2 points. So here's a point right here, and there's a point right here. This is up, all of that. So this is 1, 2, 3, 4, 5, 6, left 1. So this is up 6. So my pattern for that one is up 6, right, up 6, left 1, like that. So that's going to be negative 6x. So this one is negative 6x. And I just need to find out where it crosses the y-axis. Now, right now I'm at 4 on the x-axis, right? I'm going to go up 6, left 1, 4 different times so I can get to 0. Now, I can graph this out, but nobody has time for that. So remember, it's going to go up 6, left 1, up 6, left 1, up 6, left 1, up 6, left 1, 4 different times. So just remember, I need to do it 4 times. So here's my hand, 4 times, right? Up 6, left 1, 4 times. And the only one I care about is the y-intercept. So I only care about what my up 6 is. So I just need to do it 4 times. Why am I doing it 4 times? Because the distance from 4 to get to my y-intercept, right? To get when x is equal to 0. All right, so up 6. So right now we're at -2. All right, -2, up 6 is going to be +4. That's 1. All right, so I got 3 more to go. Up 6 is going to go to 10. That's that. Up 6 again is going to go to 16. Up 6, I'm on my last one, is going to be 16 plus 6 is 22. So this is going to cross at +22. Okay, so just find your pattern. The other way of doing this is using point slope. So if you'd like, feel free to use the method Delta Math teaches you. All right, so I just realized that my point was not at -2, but it's at -3. So it's the same process, only it was starting at -3. So it's -3, up 6, left 1, up 6, left 1, 4 times. So -3 plus 6 would give me 3, plus 6 would give me 9, plus 6 would be 15, plus 6 would be 21. So my y-intercept is actually 21. So just be careful to make sure you read your graph correctly. These old eyes, they're getting old. All right, so let's take a look at evaluating piecewise functions graphically. So evaluate the function graphically. Find f of -5. So remember, you guys are used to seeing this, right? F of x. What does that mean? That x is equal to -5. So when x is equal to -5, what is the y value? So let's go find x -5. -5 is over here. And I can see there's no more graph here, so there's nothing. And I'm guessing in Delta Math, it's undefined because it does not exist there. All right, let's find another one of this one. Find when x is equal to -2. So -1, -2, when x is equal to -2, oh, that's a hole, so that's nothing there. That's also undefined. But over here, I have a dot, which means that is equal to -3. So when x is equal to -2, y is equal to -3 because that's a dot. So remember, a hole is also undefined, does not exist. All right, taking a look at graphing piecewise functions, nonlinear. Graph the piecewise function. Okay, so with this, you really have to know your transformations, okay, that inside-outside stuff. I'm going to quickly teach it, but this is not going to be enough. You really need to rewatch a video on it. All right, so here are the notes for it. You do need to ask yourself these 6 questions. The first one you're asking is if it's inside, outside, or if it's a negative. All right, if it's inside, it's x and opposite. Outside, y and regular. If it's a negative, it's opposite no matter where it is. Once you ask this question, you then ask this question. If it's pluses and minus, you're shifting on the x or the y axis. If you're shifting on the x, it's horizontally. On the y, it's vertically. If it's multiplication, it's a stretch or a shrink. Remember, fractions less than 1 are shrinks, and then anything greater than 1, including fractions like 4/3, is a stretch. Negatives are flips over the x and the y axis. Okay, so you're answering these 2 questions. So I'll give you some more examples again. This is outside, so it's y and regular. So whatever you think, it's regular, but in the y direction. Then you come and ask yourself this. What is +5? Is it plus or minus, multiplication, or negative? It's plus or minus, which means it's a shift. On what axis did I just say? Y. So it's a shift up the y direction because it's what you think. Okay. If this is inside, so I can see the +3 is inside. So I come and ask myself this question. So it's inside, so it's x and opposite. So remember, it has to do with the x and opposite of whatever you think. All right. +3 is again a shift. +3, I would think, goes to the right, but because it's opposite, it's really going to go to the left. And again, if this is not making sense, again, go back to page 1 and watch this video in detail because that's what it's really going over. So I just want to do a couple. I'll do one more. All right, so this one is outside, y and regular. So down 2 is what you think in the y direction. This is a negative, and remember, negatives are flips over the x and y axis, and they're opposite no matter what. So this is outside. Because it's outside, you think it's y, but because it's opposite no matter what, it's flipping over the x. All right, now that you know that, let's come to the question. All right, so here's my question. I have x squared minus 1. So this is outside. So outside is y and regular, whatever you think. So if y is up and down, minus 1 would be going which way? Down 1. And it's exactly what I think because it's outside. So this is down 1. So they're going to give you the graphs. So they'll give you the parent function for this, for x squared is this, u, and you're just going to move that down 1. So I'm going to move that down 1. I just know my parent functions quite well, so I'm just going to graph it. 2, so it's 1, 1, then 1, 2 squared is 4, so 4. And then it's going to be the same on the other direction. All right, so this function has been moved down 1. Now you have to restrict it to where it does not pass 3. So let me put my boom, 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 boom. All right, so closed circle. Okay, so it includes that, but does not pass it. So this is what my graph is actually going to look like. Okay, and on this one, it stops right over there somewhere. Okay. All right, so for this other one, you need greater than 3, so everything on the right of 3. And you have to start off with your parent function. So what does the square root look like? It looks like this. Starts at 0, 0. Then let me pick numbers I know, like 4. Square root of 4 is 2. Okay, so I know those 2 points and I can draw it from there. But again, on your Delta Math, it just draws it for you. And I need to do what to it? I need to go down 1, because that's outside. So down 1, so something like this, right? And then this says go right 3, because it's x and opposite. So right 3, so move 3, so something like this. Okay, so now I'm just going to do that drawing here, but you, again, you can pick up the whole graph and move it. So for me, down 1, right 3. So I'm going to start here. Down 1, right 3. So right here, does it include it? No, it doesn't. So make sure this is an open circle here. All right, and then down 1, right 3. So I was initially at 4, 2, 4, 2. Down 1, right 3. 1, 2, 3. All right, so something like so. All right, but Delta Math will graph you the parent function. You don't have to graph it like I did, but you do need to know the rules of inside and outside and what happens when you're doing it. So again, please feel free to look back on that notebook. All right, number 7. I think this is evaluating piecewise functions is what it looks like. Find f of 2. Okay, so we evaluated from a function graphically. Now we're going to evaluate from a function algebraically. So where would 2 be? So this is x is less than 2, but x equals 2 is right here. So it's going to be -4. So the value of when x is equal to 2, when x is equal to 2, y is -4. All right, what about when it's 3? Where would 3 be? So 3 is what? Greater than 2, right? So then I would use this function here, and I would plug in my value, which x is equal to 3, over here. So 3, and you can just do this right in the calculator. 3 minus 4 will be -1. -1 squared is 1, times -1 is -1, minus 3 is -4. So again, you're going to plug that in using a calculator. Just remember when you put it in a calculator, anytime you see x, put it in parentheses. All right, so when f is equal to, find out f of 0, x is equal to 0. So where is that? That's going to be on this equation, because less than 2 would be where 0 would be. So we're going to plug 0 into this equation right here. So 0 times any fraction is going to be 0, plus 2 is 2. Okay, so that's how you evaluate functions algebraically. Find out which function it is you're using, then plug it in. All right, taking a look at visual domain and range, determine the domain of the following graph. So remember, domain is your x values left to right. Okay, so starting on the left side, so I'm going to start on the left. What is my greatest value on the left is going to be -11. And going from the left to the right, all the way to the right is what? 10. Now you just need to know whether it's open or closed in that place. So it's from -11 to 10. So my domain is -11 to 10. This is closed, so closed will be a closed bracket. And this is open, which would be a parentheses. You could write it out as well as interval notation form, which would write x is in between these two numbers, -11 and 10. But now closed would be less than or equal to, and open would just be less than. So either one of these two numbers is going to work. All right, determine the range. All right, so what is the range? So range is your y values. And how does your y go from the bottom to the top? So bottom to top. All right, so let's start with my bottom number. So all the way at the bottom, there's nothing lower than -9, it looks like, right? Nothing lower than that. -9, and where's the top of the graph? So is this the top? No, because there's a point higher right here. This is the top. So it's between -9 and -5, and I have to deal with open and close. So let's look at the bottom. Is it closed at the bottom? Yes, because that's closed there, and there's a point right here. So it's closed, bracket. And then on the top, it's also closed because there's no open circle or hole. So that's also closed. So close, close. If you were writing it in interval notation form, you write the same thing. So -9, -5, and closed will include the line on the bottom. So either notation is acceptable. So domain, x values left to right, range, y values bottom to top. All right, when is this increasing and when is it decreasing? All right, so let's take a look at segment 1. If I'm doing this, what am I doing? This is increasing. If I come for segment 2, what is it doing? It is decreasing. And if I come to segment 3, what is that doing? It is also decreasing. So look at where it's increasing from. So it's increasing from -5 and stops increasing at what? 0, right? So -5 to 0. So the function is increasing on the interval between -5 and 0, right? That's segment 1. Is then decreasing on the interval, so from 0 to where does it stop decreasing? -5, from 0 to -5. All right, and then segment 3, that's segment 2. And segment 3 is also decreasing from 5 to 8. So from 5 to 8. So whether it's increasing or decreasing is all you're doing for this question. And you just need to know where in terms of x are you increasing or decreasing. So break it down into those segments and look at your x values. All right, end behavior graphically, it's just exactly what it sounds like. What's happening at the end? So all you got to do is just look at the end. So if I look at the end on the left, where am I going? Where does this number keep going to? -infinity. If I look at the end on the right, where's this number going? +infinity. So you're just looking at what's happening on the right and on the left. So on the left, when x is very small, so as x goes to -infinity, and I can't see right here. So as x goes to -infinity, y is going to -infinity. So it could be this one or this one. Okay. And then as x is going to the right, so as x gets bigger and bigger, y should also be getting bigger. So as x goes to the right, y is also bigger. So it's actually that answer, because this one, as x goes to the right, y is getting what? Smaller. That's not true. All right, so that's the answer right there. So what's happening at the end? So this is going to -infinity as x goes to -infinity to the left. And as x goes to +infinity, y is also going to +infinity. All right, finding limits. Now this one I had to type it in because they couldn't give me the function. All right, so I showed you what I'm typing in. It's just a matter of you knowing your number line. So you come and find out what it is they're asking you to get to or close to. So they're asking you for the limit as you get closer to -4. So what I'm going to do is this. I'm going to draw it on a number line. -1, -2, -3, -4, -5, right? So they're asking me, as I get close to this, from the left and from the right, what's happening? So from the left and from the right. Now you have to know what those numbers are right here. So this number here is what? -4.1. This number here on this side is what? -3.9. And all you do is make those numbers like less and less. So this would be -4.01, then -4.001, then 0.00001, 0.000, etc. And the same thing with this. Make it closer to 4 is 3.99. And just keep adding that 99 to each time. So -3.9, 99, and so forth. So as I'm coming from the left is this one. This is left. All right. As I'm coming from the right, this is the right. Okay, let's see what's happening to my y value. So as I come from the left, y is becoming what? It's getting close to what number? To -2. So from the left, it's getting close to -2. From the right, this is getting close to also -2. So if your limit as you approach from the left is equal to the limit as you approach from the right, then the limit as you approach whatever number that is that number which is -2. If these numbers were different, then the limit would be does not exist. All right, then finally, after you find the limit, so what's happening as you approach, they're asking you to actually evaluate it. So evaluate it at x equals -4. What's it equal to? -2 in this case. All right, so in this one, you're going to have to put it in there so that it shows you these numbers because I don't know what the function is to kind of duplicate it. All right, finding limits from graphically. All right, so again, the concept is the same, left and right. So first find the number they want you to go to, which is -3. So here's -3. All right, what's happening as I come from the left? So as I come from the left, I'm coming from the left. What's happening? Where am I going? To infinity. So as I come from the left, I'm going to infinity. All right, what happens when I come from the right? So let me just use a different color. As I come from the right-hand side, so here's the graph, I'm coming from the right-hand side. As I'm coming close to that number, where am I going now? To -infinity. So that's going to be as I come from the right to -infinity. And again, remember, like I said in the previous question, if I'm coming from the left and that number is not the same as I'm coming from the right, then that limit does not exist. These numbers have to be the same for it to exist. All right, what about evaluating at -3? So at -3, is there a graph anywhere? No. So this is undefined. If there was a dot somewhere, then it would be that dot. But right now, this is undefined. All right, so these are the longer questions, and these are going to be worth 4 times any questions. So each of these is worth 4 times any questions. So let's go through it. Determine each feature of the graph of these functions. So the very first thing you have to do is go ahead and factor it. So first off, I can take out 2 out of here. So this is going to leave x squared. Divide by 2 is plus 4x. Divide by 2 is plus 4. And then on the bottom, I can't do anything, so this is just x plus 2. All right, let's go ahead and factor this top. So I need 2 numbers that multiply to 4 and add to 4. 2 numbers that multiply to 4 and add to 4 are 2 and 2. And then do I need to fix the signs? No. So this top part is going to be 2x plus 2, x plus 2, over the bottom, which is x plus 2. All right, once you factor, then you can answer all the questions. And again, if you need to reference your notes on it. But this will be the notes that I'm going to be using, but I'm just going to be talking through it, right? So holes, do I remove any part of the equation? And I set it equal to 0. Whatever I don't remove, that's my vertical isotope when I set it to 0, etc. All right, so I'm just going to be saying it. But again, if you need a more in-depth video, watch them individually. So I'll start off with my holes. I don't know why it's at the bottom, but I'll start off with my holes. Can I cross anything out? Yes, I can. So boom, x plus 2 is a hole. So set it equal to 0. So what does that mean? X is equal to -2. So my hole happens when x is -2. And now I have to find what is my y value at x equals -2. What you do is you plug it back into your equation without your hole. So I'm plugging it back into this equation right here without the hole. So this is all I'm plugging it into right here in a calculator. -2 plus 2 is 0 times 2 is 0. So my hole happens at -2, 0. Again, whatever is left over, you're plugging x into whatever is left over. Okay, so that's my hole. Now I'm going to look at my isotope. Once I get rid of my holes, I take my denominator and I set that equal to 0. So what's left on my denominator? Nothing. So I have no vertical, that's a vertical. This order is so different, but yeah. So I have no vertical isotope, so I click this one. Once I have my vertical isotope, the next one I'm going to look at is a horizontal isotope. When I'm looking at the horizontal, I want the greatest power. So I'm looking at the equation like completely multiplied out. So this would be like, actually it's right here. The highest power, this is going to be 2 and this is 1, right? So the denominator is less than the numerator. And for that, you just look at your notes. So denominator is less than the numerator by exactly 1. There's a slant isotope. You find that by dividing, but here in pre-cal, we don't need to know it. So here there is also no horizontal isotope. I do know there's a slant, but it is not horizontal. So no horizontal isotope. All right, moving on to the next one. Let's find our x-intercepts. All right, so your x-intercepts is first find out what are your domain restrictions, right? So I start off with my regular equation. X cannot be equal to -2 because that would be divided by 0. So my domain restriction is x cannot be equal to -2. Because if x is equal to -2, it'll give me a denominator of 0 and it'll give me undefined. So once I know that, I set the numerator, here's the numerator in simplet form, equal to 0. So if I set that equal to 0, and I guess I just write it out. Equal to 0. I have this piece right here is equal to 0, so that's x equals -2. This piece is equal to 0, so that's x equals -2. But you can see, can x be equal to -2? No, because that's my domain restriction. So there's also no x-intercepts. So here, no x-intercepts. Y-intercepts are a little bit easier. So remember, y-intercepts is when x is equal to 0, right? When x is equal to 0. So you go and plug in 0 into your equation. But for me, what's easiest is if you just look at the numbers without x's. So I have 8 over 2. So 8 divided by 2 is 4. So my y-intercept is 0, 4. And then I think I found everything I need. Yes, I did. So I am done. All right, the last one is you're going to do all of this, then graph it. So the only thing that's missing out of this is evaluating it. So let's go ahead and work through this question. So again, the same thing. We're going to start off by factoring. All right, 4 goes into all of these numbers. So I'm going to take 4 out. Leaves x squared. 12 divided by 4 is 3x. 8 divided by 4 is 2. On the bottom, I don't like my x squared to be negative, so I'm going to take out a -5. All right, so I'm going to be left with x squared, and then positive 5 divided by -5 will be -1. Okay. Oh, I can automatically see if you recognize this. Anytime I have just like x squared and a minus with another number, that's the difference of squares. Okay, so that's going to make it into, so I'll do it right here. The denominator is going to be -5, and then you take the square root of the first, square root of the second, write it out twice with a plus and minus, difference of squares. All right, on the top part, I'm going to have this 4, and then I just need to find my x game. Multiplies to 2, adds to 3. Multiplies to +2, adds to 3. All right, multiplies to 2 times 1, and adds to 3. They stay just like that. So this is x plus 2 and x plus 1. All right, now that I have it in factored form, it's real easy. Where are my holes? So there's a hole at x plus 1. Right? So there's a hole at x plus 1 equals 0. So x is equal to -1. So there's a hole where x is equal to -1. What's the y coordinate? Plug in -1 back into what's remaining. So I'm plugging it back into here. So this is going to be, again, use a calculator. -1 plus 2 is 1 times 4 is 4. And then on the denominator, -1 minus 1 is -2. -2 times that is -10. This simplifies to 2 over 5. And again, you're just going to do like a good estimate. All right, 2 divided by 5 is less than 1. So somewhere over here, there's a hole. Okay, so just put it in. All right, vertical isotope is whatever is left over on the denominator, set that equal to 0. So I'm going to do -5 x minus 1 equals 0. Okay, divide by -5, so that's x minus 1 equals 0. Take 1 to the other side, so x equals 1. So there's a vertical isotope at x equals 1. So I go to x equals 1, and I'm going to draw a vertical isotope. So that means there's a line, a vertical line doing this, where the graph does not touch that. Okay. Now I'm going to go look at horizontal isotopes. If I look at horizontal isotopes, remember, I just care about the powers. What can you tell me about these powers? They're exactly the same. If they're exactly the same, the coefficients in simplest terms are your answer. So that's 4 divided by -5 is my horizontal isotope, all right, which is approximately -0.8. So my horizontal isotope happens when y is equal to -0.8. So I'm going to go to the y is -0.8. It's really close to -1. And this is a horizontal isotope. So horizontally, something like that. All right, so I did vertical, horizontal, whole. Let me do x and y intercepts. So y intercepts is easy. It's just the coefficients, 8 divided by 5. And then, so 8 divided by 5 is going to give me 1.6. So my y-intercept happens at 1.6. So that's about here. My x-intercepts, okay, happens when, what are my domain restrictions? So my domain restriction cannot be x is equal to 1, right? Domain restriction x cannot equal 1. And then you set the numerator equal to 0. So this is going to be 4x plus 2 equals 0. So divide by 4, so x plus 2 equals 0, so x equals negative 2. So that's fine, it has an x-intercept of negative 2. So x-intercept of negative 2 right here. So now I'm ready to graph it. All right, so that looks like it's enough to graph this. So again, this is an isotope, which means what? It never touches, right? So it does something like this. This is a hole, so it's a hole, and then does something like that, right? But there's got to be more to this graph, which is why you have that last step, which is to evaluate the functions. All right, so we have to evaluate functions on left and right of the isotope. Now I can see I've already got the left side of this. I want to get the right side of this. So I'm just going to pick random numbers of a greater than 1 between 10, because that's where my graph exists. So ease, I've gone ahead and typed in my equation. Just remember, anytime you see an x, put parentheses. I'm plugging in my random numbers, 1.5, that's my answer. 2, that's my answer. Plugging in 5 for x, that's my answer. Plugging in 8, that's my answer. And plugging in 10, I get that. All right, so I'm going to go ahead and record it in my table just so I can plot my points. So when I plugged in 1.5, I got negative 5.6. When I plug in 2, I get negative 3.2. When I plug in 5, I get negative 1.4. When I plug in 8, I get to the nearest tenth, 1.1. And when I plug in 10, I get negative 1.06. So that just lets me know it's smaller. All right, now we're going to go plot these points. All right, so when x is 1.5, it's negative 5.6. So 1.5 in the middle, negative 5.6, somewhere there. When x is 2, y is negative 3.2. When x is 2, negative 3.2, somewhere there. When x is 5, negative 1.4. When x is 5, negative 1.4, somewhere there. When x is 8, negative 1.1. When x is 8, negative 1.1, so somewhere there. When x is 10, negative 1.06. So we're getting very close to negative 1, but we're never doing what? Touching it. So now go ahead and join all those points together. So it looks like it does this. So during my dots. Okay, so now I have a whole picture of what's happening in the graph. All right, so you have 5 things that you need to find for in order to graph. You need to find any holes, vertical isotope, horizontal isotopes, x and y intercepts. And then if that doesn't give you the whole graph, you need to evaluate functions to the left and to the right of the isotope so you can get a whole picture. All right, let's practice.